Hello and welcome to this third video in showing you how to make Perlin Noise terrain or procedural terrain. And last video, video 2, we stitched together all of our Perlin tiles. Here they all are. And I left you in the last video with a bug where we tried to put our Perlin tiles together, but they weren't lining up in the correct way. So the first thing I need to do is show you how I fixed that. And then when I was fixing that, that also caused some other bugs, obviously, and so I was kind of glad that they happened off screen, so I had a chance to think about them, sort them out, and now I can show you what's going on. Let's just put my timer on. I've gone for like an icy blue timer, just to keep things nice and cool, nice and peaceful, no big problems, and also I've made a car. Last episode video, I said I'd make a big car with massive wheels, and I've done that for you because you were so nice and watched. And that video wasn't great, so we've got a car, and it's obviously pink. So look forward to that. So first things first. Let's bring up our code. So we're in the right place. So everything was okay in our terrain brain. So that was our terrain manager that created I think we had 16 tiles, and then we worked out where to put them and kind of translated them into the correct position. That was all okay. So what was wrong, I worked out, was if we go back in the hills are alive script. So this is the script that is attached to every Perlin tile, if you remember from the first video. So we didn't really look at this script at all in the last video. And all we have to insert is this. So we are in the for loop where we're going over every single vertex in our Perlin tile. And I think we found out they have 121 points, each with an X, Y, and Z location. And what we're doing is just timesing its X position by the scale of the Perlin tile itself. So this transform local scale X. I'll just go into Unity to show you exactly what I mean. So I've clicked on the Perlin tile prefab, and its scale is actually set to 4 in the X and the Y in the Z planes dimensions. So when we're calculating the Perlin noise, that's really important. I forgot that in the last video, because basically we're mapping a kind of space in this abstract Perlin noise world, and we're mapping that onto our Perlin tile. So we've got to scale up that abstract terrain onto the scale of our Perlin tile. Okay, so back to the code. To scale that up, we just have to say this X, the position of the tile, which is this transform position.x, plus the X position of the individual vertex, and then we just scale that up, so we multiply it by the size of the whole tile. So in a moment, I'm going to rescale that to say 0.5 or 2 or 1, and everything will seamlessly stitch itself together, so avoiding the bug. And then I do exactly the same for the Z dimension. Okay, that's all I do. So well, that's not all I do. I then had a couple of other bugs which I'll show you in a moment. So let's just go back to Unity. And so on our prefab, at the moment the X and the Z is set to 4, so it looks something like this. And let me press spacebar and you can see it rolling around. Right, so if I, let's say, change that to 1, our terrain will now look like this. We've still got our 16 tiles, but now each one of those tiles is like quarter of the size. We've reduced the length of the X and the Z from 4 to 1. Okay, and what you'll notice is it kind of looks better. You've got like a smoother overall texture. And if indeed we reduce this to something like 0.2, so each tile is now only 0.2 units in the X and the Z, we get this tiny little thing, and it's like really, really smooth. So if you think about it, what we're really doing is crushing all of those 121 vertices into a tiny space. And remember, there's 16 tiles altogether, all squashed together. So we're basically raising up the resolution of the thing we're dealing with. So I'll just stop this because the balls were falling and it was getting annoying for you, I imagine. So let's just put this back to 1. No, actually back to 4, where we were to begin with. So something to keep in mind is massive terrain or something. We'll look at that in the future. But the bigger you get, the kind of you start to lose resolution, and that might be a problem for you. But just to let you know, you can kind of fiddle then with the gradient that you're applying to each individual tile and so forth. Okay, so we're going to get a car on here very soon, and we can drive around our hills. But another thing that happened was, we'll go back to Terrain Brain. So 2 things. Remember before I got stuck when I was kind of saying what we were doing before was instantiating our new Perlin terrain tile and then putting that at, I think we put it at 0, 0, 0, so vector 3.0. And then we were translating it. I've still got that code ghosted away here. We were then translating it across the x-axis, and then we were translating it across the z-axis to get it in the correct position in the grid. And then I stopped and said, I'm sure there's a way where I wanted just to put it in the right position straight away, so that would be more efficient, so we wouldn't have to slide it around. And so I found out how to do it. I realized what I was doing wrong. I didn't read the error that was delivered to the console correctly. And so I've gone back to put my position, which is a vector 3 object, which I've created here. So what I wasn't doing, I wasn't defining where the y component was for that vector 3 position. So that's why I couldn't simply position the tile to where I wanted it. So if I don't give the tile a y component, the vector 3 a y component, it will simply working out where its x position was, its z position, but then it didn't have anything in the y, so Unity didn't know what to do with it, so it's kicking out an error. So I'm just making sure that y equals 0. In fact, that shouldn't be 0, that should be terrain o dot y. And that's because if we click on our terrain manager, that terrain O is the top left corner of where you want to begin building that grid of terrain tiles. And maybe we say, well, actually, we want to create like a terrain up here, and we wanted to create a terrain down here. Maybe we've got 2 terrain managers going on. So we could put this one -12. And so now the grid will begin at -12 because -12 is held in terrain O dot y. There we go. Okay, so what I was doing was, so now I just create this vector 3, my position. I assign that my position with whatever the user has put in for the terrain's origin. So that's these 3 components. Those 3 components go into my position. So then we then add to that original position. So that's going to be the top left of the terrain. We add on what we calculated last video. So that's basically working out where it is in the grid. Okay? And then we just instantiate the tile prefab here. And the second parameter is the position that you want that new object. The third parameter is its rotation. And as explained in the last video, I've just said quaternion.identity, which means no rotation. it means 0. Okay, I realised I've basically just talked for 10 minutes. I'm so sorry, but that almost works out all of the bugs. The final bug that I had was that when I started instantiating the game objects, and I was getting an error. And this error was because I've gone back, sorry, to the hills are alive um, code script. In that script, I was grabbing these two components, the mesh filter and the mesh collider. So all of that we did in the first video. And I used to do that on instantiation, which works fine if your object has existed from the start of your program, your Unity scene. When you run a Unity scene, it goes to all the start functions of all the objects you've got in the scene. However, or it should do it from the instantiation of that object. However, when my grid was or my manager was creating all of the tiles, for some reason it wasn't grabbing these components in time, and so when it tried to run the generate Perlin hills function, it couldn't get hold of the mesh filter. So all I've done is, to avoid that bug, and I'll put a link to this new updated code so you don't have to type it out or change it yourself, although it's good practice to type it out yourself. I've just added, if my mesh filter equals null, so if I haven't got hold of my mesh filter yet, go to grab components. So I've just now copied and pasted what I used to have in the start menu. It's not Windows 95. In the start function into a new function that I've made called grab components. And so whenever you try to generate some Perlin noise on the tile, it first just makes sure that it can get hold of the mesh filter. So that's another bug that I encountered that I've dealt with. I've also just added public to the generate Perlin hills. So that means to the generate Perlin hills function, that means I can, from the terrain brain script, I can write net new t, which is the new tile, get component, the hills are alive. That's how to grab a script that's attached to another game object. That's really handy. So just like you would grab any other component, to grab the script that you've written, you write get component and then the name of the script. It will come up in the menu for you automatically. And then you write the name of the function you would like to run that's attached to that script. And you can only do that if you've made the function in the other script public, which I've done here. So why have I done that? Let's just refresh. So back in the terrain brain script, in that layout terrain function, after it's decided where to put each individual terrain tile, it instantiates the game object, and then it calls that function to generate the terrain where it's located. So I don't try to run this from the start function in the hills are alive. Okay, sorry, a lot of explanation. That was almost, I'm really sorry, 15 minutes of explanation. Let's now get a car onto this script. Okay, so I'm going to enable my car, which I've set up. I've also made the wheels really big. Here we go. There we go. And obviously I've got it pink. I'm just looking at those poor balls. Let's stop those balls. I don't know why they're all... Have I left the terrain manager on -20, -12? There we go. Sorry, the balls are scripted. I've written a little code. If they fall too low, then they'll start in their original position. Okay, so we've got a car that we can use. Can I get the terrain moving? See if I can do all of that. Okay, so now I can in a more fun way, kind of talk about the terrain. So there's another final little bug that we might as well deal with. This is kind of like a debugging video, I guess. But within the 15 minutes, we've overcome everything. You'll notice that down here there's like a line of symmetry. I wonder if we can even see it. We can kind of see it here. There's a line of symmetry. And that's not very good if you want to create kind of realistic looking terrain. And it happens because this line is 0 in terms of the position of the terrain. And so this side of it, perhaps, maybe I'll go back to this view and stop there. This side goes less than 0, so it's going to go into minus numbers. And so all the Perlin noise will do is kind of like mirror itself along the negative axis. So to overcome that, hopefully this will work. Let's go back to the code. So we want to be in the hills are alive code. That's where we're generating and dealing with the terrain. What we can do is, remember, px and pz are what we're feeding into the Perlin noise function. And that's basically finding a location on the Perlin noise. If you've forgotten what that really means and you're unsure, go back to the first video just to remind yourself quickly. We're basically finding a position on like a two-dimensional grid within the Perlin noise. And so what's happening is that position is based on where we're placing the Perlin tile in our game scene, in our Unity scene. And that might be in a negative position on the Z or the X-axis. So all we have to do is add, say, a really big number to this. So that if we're like minus 200,000, we're going to be that number plus a massive number. So why not add 1,000,000 to it? Let's just say 1, 2, 3, 4, 5, 6 zeros plus this number. So now, even if it's in the negative by somewhere less than 1,000,000, we're okay. Okay, I've saved that. Let's just see if that actually works. I don't know if you can hear the shower. Someone has gone into the shower. But that's okay, that's lovely. Right. I've also had a shower, and that's why I feel a lot fresher. Okay, now, looking at our terrain, we've got a bad seam line because of my texturing, which I don't know anything about, but we've now not got that mirror imagery going on, so we've got slightly more realistic looking terrain. Let's give our poor car a break and see if we can just reduce our tiles to 1 so that we get smoother looking terrain. I don't know if the car will still fit. Fail. Brilliant. Let's maybe it'll fit on with 3. And what I could do, of course, is kind of smooth it off in terms of the gradient on each individual tile. There we go. Okay, it's a bit easier to move the car around. Also, why don't we... I've also prepared, a little earlier, a smooth follow script, so that now we can... It's kind of like a first-person-y kind of thing. So now our camera will follow our car around. I've just hit a ball and toppled over. That's a disaster. Everything was going so well for a moment. I'll try again. What will be really fun is to switch on the wavy effect. I'm just wanting to drive around, guys. I'm really sorry, just to show you the terrain that we've made together so lovingly. Okay, let's fiddle with the... what am I looking at? No, I want to look at the prefab of our tile. We can make the height, we can keep the height the same, but we'll make the gradient a lot bigger, something like 25. So that will kind of smooth out the hills. so that I can drive, hopefully avoiding those balls, which are problematic. Okay, so now I can drive around, and we can enjoy our terrain. So the future step will really be to when we've moved a certain distance, we want to say grab a terrain tile from the back and place it in front of us so that we can continue driving, and then keep on doing that. So then we could have like an infinite procedurally generated terrain, which is definitely what I want to do. Maybe in the next video or the video after that. Next, I think what we want to do is we want to make almost like biomes or kind of an even more realistic terrain. Um, what else? What else do I want to do? Maybe start. Okay, we'll start next video. We'll try and do the infinite terrain idea, but also make our terrain look a bit more realistic. But there you go. So this was not a great. It was an okay video. You got a giant car, and if you want to know how to make the giant car thing, which doesn't take very long, and is completely free, um, let me know in the comments, and I'll do that for you. But what do we want to do? So next video we want to make it a bit more realistic. Think about how to move these tiles around. There we go. So a debugging video. Thank you very much for watching. Apologies if this wasn't too useful. There we go. See you. I probably won't see you next time. You've probably given up now. This is probably too much. Okay. Bye.